Hi, everyone. Thank you so much for coming to this talk. Today, I'm going to be talking about Flibble, a tool to bolster text transfer between Elan and Flex, on behalf of myself, Sankalp Ananthnarayan, and my co-authors Amalia Skilton, Sophie Pearson, and Claire Bowen. So first, I'll just go over a brief roadmap of what we're going to be talking about. First, I'll give an idea of what the spoken language documentation workflow can look like, then talk about the problem that came up that Flibble solves, which is the Elan to Flex to Elan data flow for child language acquisition research. I should note, though, that if you're interested in this workflow, but maybe for different kinds of research, probably worth sticking around because it is very relevant for different kinds of things. Then I'll introduce the software itself. I'll talk about the data structures and data flow and how to use it. And then I'll make some concluding remarks. So the spoken language documentation workflow, it can take many different forms, but one very common thing is that it's a lot. There's just a lot involved in it. So what we're going to do is limit the scope for this talk and just talk about what's in transcribe and below. And so this often involves the tools of Elan and Flex. So Elan is the logo on the left, and Flex is the logo on the right. So I'm just going to go into that really quick. Elan is where people often transcribe texts. They'll translate them, make notes, and add annotations. And Flex will have people taking texts that have been transcribed, glossing them, and making a lexicon out of them, and iteratively improving that lexicon. So often, as one might imagine, a transcribed text from Elan might be imported into Flex so that it can be glossed and so on. Flex often has an export. Flex users often export their text into Elan so that they can do things such as further corpus work, things like prosodic analysis, gestural analysis, counts and statistics, and preparing things for archives, etc. So what Elan looks like when you're using it is this series of tiers with texts that have been annotated or filled in with annotations. And these are time aligned to particular parts of a media item, such as audio or video, and it's used for sign language or spoken language or multimodal annotation. Flux, on the other hand, is really only used for spoken language transcriptions and written language. It involves a lexical database as one part, and then transcriptions. And through a very powerful morphological parser, it glosses texts automatically, or rather, it suggests glosses for the user to then approve. So going from Elan into Flex, you can take that lexicon that you have in Flex and you bring in a text, you import it into Flex from Elan, and that's what can get glossed. And so that's what we have in this example. And then people, again, like I mentioned, go from Flex to Elan. So going from Flex to Elan, one might take this glossed text and hope to get something in Elan like this. And that's what one can do. Then from Elan, maybe you want to get statistics out of it, and so you'll go to a CSV file. And this is very straightforward as well. There's an export function that gets you here. Now, where the problem lies that we needed to solve was in child language acquisition research, specifically that of Sophie Pearson and Amalia Skilton. They're working on Ayuk and Ticunas, respectively, in Oaxaca, Mexico, and Peru, again, respectively. They're both interested the comparison of discourse contexts of child speech, child-directed adult speech, and adult-adult discourse, comparing these things. As well as within children's speech, differences in development and acquisition of concatenative and non-concatenative morphology. So they need to be able to look at things like templatic morphology and do statistical analyses based on frequencies. So all of this, what did they need? They needed to use naturalistic data, and this meant they needed to have ungrammatical utterances because these are children. They have language that maybe isn't developed depending on your theory. It's incomplete acquisition or what have you, and so there's interesting things there when it's an ungrammatical utterance, and so we want to keep track of that. We also have conversation with multiple participants necessarily. So when it's a conversation, we need to be able to keep track of who the participant who's speaking is and who they're talking to. When there are ungrammatical utterances, we need to be able to associate the grammatical utterance, the phonetic one, the ungrammatical utterance, what was said, the phonetic one, and the grammatical one, the target utterance, which we might propose that the child has been trying to say. Now, the issue with, for example, with Pearson's work is that there are 72 hours of audio texts. So we need a parser. We need something that'll be automatic and quicker than doing it by hand because that will be just so slow. And we also want to be able to do statistical analyses. So we do need this CSV export so we can take it into R or other statistical software so that we can get counts and propose analyses. So another way of visualizing this, we have these needs, and it is clear that Elan meets a lot of these needs, but very, very notably, it does not meet this morphological parse. It does not meet that need. So we do need Flex for this. Flex does lack the ability to time align your transcriptions. It does have a translation field along with the transcription, and it does not have a place to put participant or addressee, and there's no way to link a target utterance with a phonetic utterance, and nor does it have an export into CSV. I said there is no time alignment, and I said there is no speaker noted in Flex. That isn't quite fully true. In Flex, we actually do have these things. So this is the XML format internal to Flex that it stores, and it does actually have the beginning time offset, so from when the audio media begins, and then it also has the end time offset, so when the utterance would end, and the speaker. But it's only internal. It doesn't appear in the graphical user interface. When someone opens Flex, they don't see any of this stuff, or they don't see those three things at all. So we'll say they're kind of there. Okay, how do we get the addressee in? When we're trying to get from Elan into Flex, if we're trying to do it, how do we get these things in? An addressee, maybe we try to force it somehow. We just like put it in manually or something like that. Now getting the target utterance, that one's going to be difficult. We needed to figure out how we can link two things between the transfer from Elan to Flex and make sure they continue being linked when going back from Flex to Elan. That was the crux of this issue, and that's what Flibble is so helpful for. And of course, there's not going to be a way to do the CSV export because that's just not available in Flex. I will note that Elan does have an interlinearization mode, but there are some issues with it that make many people want to prefer to use Flex. Also, people use Flex already. Their workflow is already set up to optimize Flex. So instead of trying to get people to change what their project is stored in at the moment, this is a piece of software that we've built in order to help what's already going on. Perhaps Elan's version will become better and worthwhile, but transferring an entire project into that is quite a lot of work as it stands. So this is meant for people who are already using this process and want to make it better and more thorough. So let's go back to this import idea if we want to bring Elan into Flex. One thing that we might notice, though, is that there's something missing. We don't have the transcription. We have the target utterance right here, this one that starts with Tavan. That appears in 8, but it doesn't appear anywhere else in the Flex text. And this XDS, this X-directed speech, so who the addressee is, the addressee does not appear anywhere in this utterance. It's not marked anywhere. So the goal of Flibble is to make sure those things come in as well. And since those things don't get included when going into Flex, why would they be included going into Elan out of Flex? And then why would they be included going out of Elan into a CSV? Of course they wouldn't be, so we can't do anything with it. So here we go. Here's our solution, Flibble. The core issues, again, are that Flex allows for the baseline text, so what was actually said, the transcription. It allows for morphological information, the breakdown, part of speech, sense number, things like that. It allows for a translation, and it allows for notes to be associated with any given utterance. So any number of notes too, which is great. Elan lets you associate any number of tiers that are time aligned with each other. We need to be able to allow Flex to take in any number of tiers to any, just so that it would accommodate whatever we have in Elan, or we want to maximally do so, or at least make it possible for the work that we're trying to do. The way we do that is just use notes. It's nothing special, really. Ultimately, it's not something hacking into the program and making it a new thing. We're using what's there, and so what we're doing is we're making a note that says this is the AID, the annotation ID of the original annotation that is the top tier, the transcription, the phonetic tier, and then reference that same AID in the target utterance. So bring in the target utterance as a new utterance and keep a note under that one that says, hey, this is a target, and the AID that it's going to refer to is this one above it. And for the phonetic one, have that same top tier AID there, so then we can match them. Likewise, for notes, we're going to put the speaker code and addressee code in the notes as well. So here we go, our solutions. We're not going to take the timeline transcription because it's actually not something that we need. So we're going to keep that in the XML. Sorry, not timeline transcription, but the time alignment, the number of milliseconds that the utterance occurs after the beginning of the media. We are going to keep the participant in a note, though, and because we want to be able to look at that, because maybe that'll inform how we make our analyses while we're going through Flex and making the morphological parse. We're also going to bring the addressee in a note, and so that's what we're going to do. We're going to force it into a note. And we're going to do the target utterance by having this new utterance, this separate utterance, and have a note that refers to the same AID and says, hey, I'm supposed to be a sub node of the original parent, the top tier node that has the phonetic utterance. And then, of course, we're not going to be able to do the CSV export, so we're going to need Elan. So just talking about what the data structures are like for Elan and Flex and what Flibble does, I want to say that this is not what you need to be doing if you're using Flibble. This is what Flibble does in case you're interested in the kind of inner workings. So this is what XML looks like for Elan. XML is this language that people use for lots of different kinds of things. In this case, Elan has designed theirs in a particular way. You don't need to be able to understand everything that's going on here, but generally this is what it looks like as kind of a template. You have an alignable annotation. This is what I've been saying the top tier is. That's what's time aligned specifically. And then you have reference annotations that are dependent on that top tier, that alignable one. And so we can see that they reference A1. That's the AID that I've been mentioning. And so this is the top level AID, A1. And then these all have their own unique AIDs, but that's not what we're referring to. We're referring to A1 because that's the top level tier that these all are dependent on. And so it even says the parent reference is this one, parent MTO phonetic. Likewise, we can see that the tier ID for this top tier is parent MTO phonetic, and that's what all of them refer to. So we have each tier being its own thing, its own element in the XML. Unlike that, we have each phrase, each paragraph in Flex having its own special object. So this is very distinct in that it is deep. We start out and just go in and in and in and in, and then we get our information, our text from the utterance. So we keep metadata at different levels of this in Flex, but we have the text itself very late as we dive inward in the XML structure. So just comparing them, the Elan one is very flat, Flex is very nested. So what do we do in order to get them to speak to each other? We have an interchange format. And so I designed a JSON format that would take something from one, make it something sort of in the middle, and able to be moved in either direction. So this interchange format is like Flex in that it takes each utterance as an object instead of being tiers. And then it's more like Elan in how it associates tiers, and it also does away with a lot of the redundancy that Flex texts use. And it's also in JSON. It's not XML at all, which means that from JSON we can go into different programming languages and access these things a bit more easily. And it's also a little bit more human readable than XML, but that's maybe personal. It also has the ability to be, you can go into it and add dimensionality. If you want to thicken a gloss, you can say, I want to add a note here or add extra bits here, add a little array of parts within this part. You can do that pretty simply with JSON without having to create an entire XML node to do so. And this is what we do in Flibble to connect two related utterances. A target and a phonetic utterance are going to be connected with this original AID tag here that says A558 for this one, A558 for this one. We know one of them is phonetic, one of them is the target. So we're going to connect them when we're going back into Elan. And when we're going into Flex, we're going to use this information to say, put these two next to each other and make these notes. So in both directions, this is used in order to connect these utterances. So how it actually constructs these files, importantly, it bypasses the native Elan export and import and does it by hand. It's a programming language. It's a program. It does it by itself, but it basically doesn't use the Elan export and import into Flex texts because it just uses the EAF files, which you have. If you're using Elan, you have these EAF files that you open every single time. It just looks for those and grabs it. So in order to do that, it makes this interchange JSON format. It takes the annotation IDs that are relevant in order to store phonetic versus target, and then it stores the speakers and addressees, and of course it stores the text. And then it creates the flex text from that JSON object. Creating the flex text, we match any speaker AIDs, parent AIDs for phonetic and target utterances, make sure they're next to each other, get the notes for speaker addressee, generate all the things that Flex needs because it's special in terms of its format, and so we make sure it's valid. And what Flibble does uniquely is it creates these notes that allow these things to be parsed correctly when we're doing analysis. Flibble going from Flex to Elan will make a JSON-like object, again, that interchange format, and we'll make these AIDs into that original AID tag that I showed you earlier. And then make the EAF file. So I'll make all the annotations and add references to the parent nodes using the original AID tag where necessary. And one of the unique things that this does, it allows us to use speaker codes instead of tier names that are just A, B, C, D, which is what Flex would normally do when you're exporting from Flex to Elan. It also lets you link dependent tiers that need to be annotated individually. So this is where I'm talking about with the phonetic and target utterances, because we want to be able to annotate them as though they're all morphologically parsable to whatever extent they are, instead of leaving one just as random text. And then also you can look for particular note contents to say that this is going to be going in the X-directed speech tier. For example, these looking at Pearson's data, the IOC stuff will have a T in the note if it's a certain kind of addressee, or a T plus A if it's a different kind. And so we'll use that controlled vocabulary to define a search within the notes to say this is going to go here in the XDX tier, as opposed to a general notes tier. So using Flibble is extremely straightforward. You have a configuration file where you define all the information that it needs, and then you can also process this in batches. So you just put in multiple file paths. And this is what the configuration looks like. It makes a JSON file that you then save into your computer, and then you run a Python program. This is not what's displayed in the videos that I'm showing you, but that's just because it's a newer feature that we have. So this is the Elan file. We go from the Elan file and you save that JSON into your computer, and from this JSON that you've saved, it knows to look for that file name. You just go into your console and run the Python program. It's now created the Flex text. So you have that. You go into Flex, you do your magic, you do your language analysis, then you go out of Flex and you want to go back to an EAF file. So you do you configure the to-EAF configuration file, which has different information because Elan is looking for different things. And once you fill that out, you do the same thing. You open your terminal, run your Python program, and it's going to take a little bit longer because you've now glossed your text, so it's much bigger. It has all the morphology, and then you can open the Elan file, and it's there with all of the glossing. So, bippity boppity boop, we now have, as opposed to the original way we had the export from Elan going into Flex, where you only have the target utterance that appears and you don't have any of the extra information. Now we get the phonetic utterance, and it's noted that this is the phonetic utterance. It says which AID it uses and the speaker, and then it also has the target utterance that appears below it, and that both of them can be annotated morphologically and using the Flex parser. And this is what it looks like in Elan. It has all the morphology annotated, and you can use it. Go into statistics and go into R and do statistics with it. So now I'm going to give some quick concluding remarks. Just to recap, this is a stopgap. This is a solution, but addresses some things, and they're all symptoms. Flex lacks some features, and so we're trying to work around them. There was a recent email in a Ling type listserv that mentions that there's custom text fields, which solves the speaker and addressee problem. This is unique to Flex 9.1, and that's not available on Linux, which is what I run. And it also only solves part of the problem. And there's some issues that are inherent to these tools. I will say you should come check out our poster where Flex falls flat. And this, we talk a little bit more about where Flex, falls flat as a tool. But again, we still use it. Flibble is a solution that we're using. It's straightforward to use, it's feasible to extend, and it uses JSON, which means that you can kind of bring it out into any other programming language and work with it pretty easily. It goes beyond child language, and this is really important. You can use any other kind of association of utterances. Maybe it's varying grammaticality judgment or alternative wording. Say someone says, "Oh yes, this is what they just said, and this is the translation, but I actually say it in this way in my variety." And so you want to include that, and you want to be able to annotate that in Flex, and you want them to be associated so that when you go into Elan, it's still there. Flibble lets you do that, and now you can keep track of participants and other annotations automatically. It's also not a panacea. It's a workaround, and just because we have one doesn't mean we should stop here, and we shouldn't be dependent on workaround after workaround. This is a bigger issue in the state of the field that I could talk about for hours, though. But yes, if you're going to be using Elan and Flex, maybe this could be very helpful to you, and this could make the process easier. And if you're going to be avoiding Flex because of the import struggles, maybe this could be very helpful because now you can actually use this morphological parser that makes things a lot easier. So you should talk to me, email me, sankalp.ananth@gmail.com, or just find me somehow if you want to talk about this, get a beta version. I'm super eager to hear back from people who are interested in working on this kind of thing and making these things better. Thank you very much. And thank you to our sources of funding as well. I'm looking forward to your feedback again.